straight down at this end. This is the cake discharge end with the discharge diverter chute gate down there at the bottom. Look at it, really.
Skim face.
Everybody's taking pictures. And you're like,
When you guys get done, put this paper on the shelf.
Once we've taken the front hub off of the machine, we're left with the spline shaft. We want to get the spline shaft out of the way. You don't have to take the spline shaft out. You can leave it in. I like to get it out of the way so we're not bumping our knees on it. Then we're going to remove the seal cover, which is a front conveyor bearing seal holder. We're going to remove the seal holder and expose the spline bushing. Then we're going to remove several bolts from the spline bushing so the conveyor tool mounts up, and then we can lift the conveyor out. So we're almost there. And that's it. That's good.
We didn't see any cardboard out.
Anywhere. We set it right here straight up and down. Concrete. Something underneath. Some piece of that paper.
There's a cardboard right
We just roll out a piece
there.
of
What do you
that
need?
paper.
Okay, the paper. Oh, so then left that over there on top of that insulation. Okay.
This bearing is only going to see differential RPM, even though the whole machine is turning 2,800 RPM. This bearing's only going to see differential speed, which is could be 8 to 12, 15 RPM.
That's just a full.
It's just a slow roller, even though the whole mass is turning. So it's minimal speed.
We dismount all our ground.
Shift across country,
Yeah.
probably rode on the back of the truck over the back wheels. First place you can put it. So I always back these out really far, verify that there's no bolts sticking out. Wrap this up in paper. We're going to lift our conveyor bearing tool with the crane. We're going to bring it over here. We're going to look at the bolt pattern on the tool, and we're going to decide which one of these bolts need to come out so the tool can be put on. The tool comes with its own set of bolts to attach it to the conveyor. Let's hope they're the right ones. Last one I did, they weren't. We will have to move the straps out of the way.
I like what?
You like to
Can you stick those bolts through the holes and tell me that they stick out this end?
Yep.
And they look
Only
like
about
they
3
stick
inches.
out.
Bolts too long now.
Too long, huh?
okay.
I'm sorry, guys.
You know, torque you on the top.
How about that? Well, at least they all started. Got the hand on that bearing?
Looks like it's gonna stay there.
Well, this might want to go ahead and pull it out and wrap it in some of that rag or paper. I'm afraid it's going to fall out and lose its grease seal. Ready?
Yep.
So what we want to accomplish when we're removing the conveyor from the bowl shell is to keep it suspended, not let it drag, not let it bump. We want to try to keep the center of gravity as best we can and try to scoot this thing out without it bumping or beating itself to death. There are carbide tiles inside. They chip real easy, so my best suggestion is let the crane do the work and just have a hand on it to help guide it. And it's a slow process. There's nothing in a hurry about getting it out. Drops out that bearing down there below. We have our center of gravity for good now. It's just going to drop one way or the other. Did a good job. We can manhandle it up and down with our hand here for center of gravity. So we hit it pretty good on that hole. Future reference, you might want to mark that one for clean. But once you put cake in there, if you get a cake spot, you're gonna be in some trouble. Watch the crane. Don't know how fast I'm moving. John Ruff design right here. This flight used to come straight into here on both sides when I first came to Alpha Laval. and they kept packing solids in there, and I said, why don't we cut that out and put it on an angle of rotation and put a gusset in there, and we'll eliminate that solids buildup, and we did. So, it's one of my own little tricks. Think we paid Attaboy. Some of the stuff on the conveyor that you're going to see when you pull it out, obviously we got a shitload of balance weights here on this side of the conveyor because there's no flight around this side, so we had to do something to offset the weight. BD disc, it is a flat disc called our barrier disc. This helps us run a deeper pond without sacrificing our cake dryness, and by running this BD disc we can put the deeper pond, and we can use hydraulic force on the liquid end of the machine to help scroll the cake out, not just mechanical with the conveyor itself, but actually use hydraulic force from the back side, the pressure on this side, to help push the cake up the beach and get it out, along with the mechanical force as well. This looks like the pitch in the conveyor looks like it gets a little further apart as it gets toward the end down here. I don't know if it's good to call that variable pitch. It'll just be the standard conveyor. Used to the DS706 prior to the Aldec G2 120 had 420 tiles on it. I don't know if this is 410 or what the exact number is. I'm not going to count them. But obviously the tiles go all the way back to this section here of the machine. From there you have a hard surface welding on the tip of the flights. Liquid gets through to the liquid end of the machine, gets through the gap between the tiles and the flights and the ID of the bowl shell, as well as through the liquid area here on the ports of the machine. A little bit larger here. This is our feed zone. This is a replaceable lug. It's a tungsten carbide wear saddle, and it is replaceable. So in the event that this section starts to wear or breaks, you just take this out. You put the PC7 epoxy and put it back in. One on each side, 180 from each other. You got your target in the middle, polymer injection zone here, and I guess more polymer zone there. I don't know why it goes so far back, but it does. In the event that we get condensation or liquid inside the conveyor shell here, usually when we tear a conveyor apart, we'll pull this plate that I pulled the bolts out of. We'll pull that plate out all the way. This is called the spline bushing. That's what drives the conveyor. There's an O-ring on it, and sometimes we find liquid in here. That'll have to be taken out periodically when you do an overhaul on the conveyor. Drain the water. You don't want water sticking in there. Sometimes they don't fill up at all. Sometimes they get a little water in them. Any questions on the conveyor? This is something new. First time I've seen this. Gusset in there. Balance weight here and balance weight here to accommodate no flight in this area. We minimize our welds on the tungsten carbide tiles. It's pretty much a full weld across the face, but we minimize this weld because the tile is bonded with a bonding agent to the holder, and the holder is welded to the flight. You're allowed 10% tile replacement in the field. So if we lost 10% of the tiles in various locations, we could change the tiles, we'd grind the weld out. You know, if you lost 2 or 3 tiles here, 2 or 3 tiles here, and a couple tiles over there, maybe one over here, we could replace those tiles in the field. Once we lose more than 10%, and especially if they're all in one area, then we do the welding. All the conveyor should go out for balance. Tension bar down here on this end. Basically, this is where our conveyor bearing fit is here. Our pulley bearing fit is here, and then the tension bar nut on the end, which sucks everything and preloads the thrust bearing. Tension bars are balanced independently, so if you pull one out, it can be used on any conveyor. Questions? Inside the bowl shell, we have our caulk strips. I believe this bowl is lined with a liner, so if you took the conical section off, one of these caulk strips covers a seam. Grind that seam out and this liner comes out, and you can replace the liner and put new caulk strips. in the event that you crash something inside it. Rather than having to have a whole new bowl shell built, you just take the liner out. I think it thing's probably 1/8 inch thick. Conical section, same thing down there. It has a seam in it as well. These caulk strips run the full length of the bowl. They just help direct the process axially down the machine. You can see down there we have our conveyor bearing and the seal. See, we lost a little bit of grease when we pulled it out. It dripped down. If you look inside here, you can look all the way through the section here and it takes you straight up to the target. This is where your feed tube goes inside. You asked about where water would come out if they overfed it for centrate, for CIP cycle. The gap between this tension bar and the feed tube is the amount of room you have for spillover. If you get to that level and you're spilling out here, you know you're exceeding the seal.
That means water's going in.
That means it's coming in here too much and filling this section up and then coming back out. That's an alpha valve conveyor.
How would that come out? You said there's a leak or something up here? Say,
That, let me show you on that machine where this is. If you look, the tension bar nut right here, alright, and your feed tube goes in right here, and there's a gap between the OD of the feed tube and the ID of that tension bar. So there's where your water would spill out if you were overfeeding CIP. Too much CIP water, you'd spill water out here and be pouring all on the floor here. So you ever see water coming out usually in the forward direction, the direction you're scrolling the water in. If it's too much, it's going to push it this way, and you're going to see it come out. When it's running reverse CIP, you won't see that water. It's going to go out the other end of the machine. And if you really have excessive amount of water, it's going to come out. Even though it could be in reverse, it's going to come out this end as well. This is where all the work takes place right here in this section here. And around in here, this is where you see a lot of your wear, polishing more than wear. You're going to see a lot of polishing from, if you have abrasives in your solids, you're going to see some abrasive wear. When you take this thing off, you would actually see cutting lines on the top of these tiles in the direction of the rotation, basically. And you're going to be looking for wear. These tiles have got little marks on them. I showed y'all some pictures of the big conveyor I had out. I showed you the other day. It was one all the way down to this much of the carbide, 3/4 of an inch of the carbide tile was gone. That's from a plant that has 0 grit removal, city of Cincinnati, right on the river. So they have no grit removal and run machines balls to the walls, and they don't let up for nothing. They're wearing conveyors about every 20,000 hours going in and retiling. If you catch it before you get into the flight, it's a lot less expensive for repair. And if you wore the tiles out and you're down into ½ inch of the flight is gone, then you're forced to reflight the conveyor and get it to a high dollar repair rather than just replacing some tiles. Usually I don't see a lot of wear back here in this area too much, even though we have the wear protection here. And then here on this end, this is kind of like this is where we get the least amount of wear, where the clean liquid is. So the tiles actually go back further than I thought they did on this conveyor. They used to stop on the 07, 06 right in this area here. This conveyor hub is actually a little bit different design. They've narrowed it down here to give you more room for process. So this is what's helping with this is what makes us, believe it or not, this is probably part of Alpha Valve's trade secret to make us beat Westphalia in a test. This little bit of machine down and this taper right here and this gives us the capability to run higher flow rates than most of our competitors because of that extra space there. We can fill this whole section here with solids when most competitors are only filling 2 or 3 inches with solids, and then their machine's maxed out. Well,
So
any questions on
What
it?
is the clearance between here and that?
Approximately 1/8 of an inch.
1/8 of an
1/8 of an inch and 3/16 of an inch. What we will do when we put this back in, I was telling you, we're going to find some really fine cardboard. We're going to stick this conveyor back in. We're going to stack up some cardboard on those caulk strips right underneath that last flight, and then we're going to let it down, and that conveyor would be centered inside the hub. This will help us slide our large hub on easier. If we leave it sitting on the bottom, now we've got to put the hub on, make the bearing fit, then we got to lift everything up and then make the machine fit for the hub. So if we center the conveyor up with some cardboard gets wet, deteriorates, it's gone. So it's a little tricky.
Yeah.
To do what?
But when you stuff bread in a pipe to solder it, it soaks up the water.
Oh, yeah? Bread? Rich bread?
So-
Doesn't matter what kind of bread?
I don't
Some
know
butter
what
in there with
breads
it?
So
Alright.
as this tires wear down, you take the adjustment with a nut.
Nope, that nut bottoms out, that's it. When they wear, they gotta